the first side of the paper is a lot harder than the back side, so I'll go through the first side with you. So precalculitis, it's a nasty disease going around. The probability you get it is about 65%. The most accurate tests are 85% accurate in detecting the disease when you have it, 95% accurate when you don't. Obviously, way too much information to take in at one time, so let's set up the tree. It's great to identify your two events, and what's difficult here is that precalculitis starts with a P and also positive stands with a P. So let's go, I'm going to go with D for disease, and then I will go with P for positive. Those are my two events that we're going to talk about here. All right, we'll start out the tree. Either you have the disease or you don't, so we'll go D and not D. And then from there, you're either going to test positive or you're going to go not positive. Like I said, it's a bad idea to introduce another letter like positive and negative, like a P and an N. So we got positive and not positive. Keep them the same there. All right, so the probability that you have the disease would be 0.65 right here. The probability you do not have it then is 0.35 down here. So let's see, the most accurate tests are 85% accurate when you have it. So positive is going to be 85% accurate when you have it and 15% when you don't. Now the word accurate is always a tough one because that has double meaning. When you have the disease, accurate means it says you have it. And when you don't have the disease, accurate means you don't have it. So don't think that always means that it's going to test positive. So down here, let's see, it is 95% accurate when you don't have it. So if you don't have it, accurate means it says it's not positive. That would be accurate, 0.05. We're going to take a sec here and calculate your intersection. So what's the probability that you have the disease and you test positive is going to be 0.65 times 0.85, which would be 0.5525. Got 0.65 times 0.15, which would be 0.0975. Got 0.35 times 0.05, and we have 0.0175 and 0.35 times 0.95, which is going to be 0.3325. All right, couple things to point out. If you take all these and add it up, it should add up to 100%. Those are the only things that can happen. There's 4 different events. So there's your probability distribution. And I said it a couple times, so I won't dwell on it, but this is not the probability that the test actually worked. This is random sampling. If you randomly go throughout the streets and just say, hey, you come over here, 55% of the time that randomly selected person will A, have the disease and test positive for it. All right, what's the probability the test comes back positive? I'm not going to necessarily add all these things up because I think you can do that, but if you see there's 2 ways to test positive. Here's one way and here's the other. So add those 2 up and you'll have it. The probability if the test comes back positive, it's a false positive. Ooh, false positive. What that means is that it says you have the disease, but you don't, that you don't have the disease. That's what it means to have a false positive. If I wanted to put it in symbols, it says, what's the probability that you don't have the disease, no disease, given that you test positive? That's how we would write it in symbols. So there's 2 ways to test positive. The one that you want for your numerator is down here for the one you don't have the disease. So we'd have 0.0175. The denominator, once again, 0.0175 plus 0.5525. And so there's your probability. I'm not going to go over this one. The probability you have the disease if you test positive, I think hopefully you can figure that one out. So I'll give it to you in symbols. The probability you have the disease given that you test positive. So that's going to be your given. Those will be the 2 numbers, and then you can figure out which one goes in the numerator. Now, here's the hardest one for sure. For D, suppose someone tests positive and they don't believe it. So they take the test again. What is the probability they test positive a second time? Well, the first thing that you have to point out, or that I need to point out, is that the test itself does not change. that it's 85% accurate and 15%, that these numbers right here, 85% will find it and 15% that it won't. This portion of it is not going to change. Here's what's going to happen. Once you take the test, these numbers no longer apply. 0.65, that number applies to the general population. If I just randomly sample, go out on the streets and say, hey, you come here, take this test, these are the numbers for that. Now what we're going to do is when you take it a second time, you've joined a different group. You're not in the random group anymore. Now you're in a specific group of only people who have tested positive. Okay, so let's go through this again. I think I actually have to answer question C for you. So the probability you have the disease if you test positive. So I'm going to answer this for you. The probability you have the disease if you test positive, well, your positive tests are down here at 0.5525 plus 0.0175. Your numerator, the probability you have the disease is 0.5525. So we'll go 0.5525 divided by the addition of 0.5525 plus 0.0175. So that answer would have been 96.9 or 97%. Okay, so these numbers right here for the disease are for randomly sampled people. We're not doing that anymore. Now you've joined a group of only people who have tested positive. So the probability that you have the disease is this. We're going to call it 0.969. The probability you don't have the disease now is going to be 1 minus that number. So 0.03. We'll even throw a 1 in there, 0.031. The test itself has not changed. So positive, that's 0.85, and not positive is 0.15. Down here, positive and not positive is going to be 0.05 and 0.95. Okay? I'll let you calculate the intersections and then answer the question.